Hello, and welcome to All Space Considered, everybody. I'm Dr. David Reitzel, and with me tonight is Laura Mayabron, Sarah Al-Ahmed, our special guest tonight from Planetary Radio and the Planetary Society. Woo! Yay! Ginger Rose is here, and also Jared Head is with us tonight, our normal show. Folks in the audience are saying they need a little more volume on my microphone because it's kind of loud in here, so I don't know if we can get a little more volume on the mics on the stage back there. That would be great. Anyway, but welcome to All Space Considered, everybody. It is on the third Thursday of every month, and All Space Considered is brought to you by the City of Los Angeles Department of Recreation and Parks, and we always like to thank Griffith Observatory Foundation, our exclusive nonprofit partner in so much of what we do. Now, tonight's show is really, really terrific. Make sure this is turned on here. There we go. There's our news. So anyway, tonight we're of course going to talk about some space news. We have an interstellar visitor visiting our solar system right now. There's actually an object flying through from another solar system. We're going to do an out to launch with Jared. And then we're going to talk about the Vera Rubin telescope visit that you did, Laura May. You actually got to be there. So we have somebody that has had shoes on the ground. I don't know if you're wearing boots, but boots on the ground at the observatory.
Helmets on the head.
Amazing. And helmets on the head, exactly. And then we have our very special guest, like I said, Sarah Al-Ahmed, Planetary Radio host, Planetary Society. But Sarah, you used to be part of our All Space Considered team for a lot of years, 5 years, 6 years, something like that.
Almost 6 years, I want to say.
Yeah, so before you headed off to Planetary Society, you were one of the people that made this show possible. So we're so happy to have you back tonight. And then just to have some fun, we decided to mix up our coverage of the AAS meeting. Every year, the American Astronomical Society has a meeting twice a year, one in the winter, one in the summer. The summer meeting's a little more relaxed. The science is still serious, but it's not the bigger of the meetings. So we thought we would do a sampling of the stories and have a little fun with you tonight. So we've been handing out Lotería cards. I think in the audience, all of you have them, or those that do. And we'll be calling out, and they'll be on the screen as well, which of those topics come up. And when they do, you can fill out your card, and you can yell out when you've won. You don't need to get a blackout. It'll just be a line across. You'll see. So we're going to have a little fun with it, but we're going to mix in some bingo just to mix it up. We're going to randomize the stories. We realized we didn't have time for the 25 stories or whatever they released in the press release. So we're going to pick which stories we're going to cover randomly. So you'll see all of this later. We'll explain it when we get there, but it should be a lot of fun tonight. So let's kick off the show. Let's get started. First of all, we are in our 90th anniversary at Griffith Observatory this year. And to celebrate, we've been having a little feature in All Space Considered to talk about that. And this time, we're pointing out one of the projects we did. And we did passports. Ella Ritz and Pixie Iwata got together and created a wonderful interactive passport that you can pick up here at Griffith Observatory. And the pencils that you're going to be using for the Lotería actually can be used to fill these out as well. And you can go around the building and interact with the passport and get stamps from the museum guides at the various desks. And it's just a lot of fun. It can be a nice memento of a visit to Griffith Observatory. So this summer, we're supplying them, and you can come up here and grab one of these for free. So to celebrate Griffith Observatory's 90th anniversary, we have passports. Just don't try and fly with these. It'll get you on the wrong list. So you don't want to do that. So, thank you. So to our first astronomical story tonight. This is one of the discovery images. The ATLAS program is actually looking for Earth impacting or potentially asteroids that could run into the Earth. So this is a protection to keep Earth safe, planetary defense essentially. And they found a little object, and you can see here that little object is moving. And when they calculated an orbit for it, it ended up being like that. So that's not an orbit, that's what's known as parabolic. That's coming into the solar system and flying right back out. So this is from another solar system, this object. It's called 3I because it's the third interstellar object we found. The first one was Oumuamua, as many of you know it's called, a strange object that came in. It actually accelerated on its way out. We think it was probably a comet of some sort, although we didn't pick up any outgassing, but that's one way you could accelerate. Then there was another comet, 2I...
Comet Borisov.
Borisov. It finally got its name, full name Borisov. I think it was found by ISON, I think was the survey that found that one. But Borisov was the astronomer that found it, and they're named after the astronomer, so they can. So that was the second one. That was definitely a comet. We saw outgassing on it, and it had similar features to a solar system comet. It wasn't greatly different, but it's still, even minor differences can tell us things about other cometary areas around stars. Now this one is definitely also a comet. This is an image that was taken by the Gemini Observatory, and they took it in several different colors. As you can see, the image on the left has the different colors and the spots that were taken. They combined them to get the image on the right. And you can see it's fuzzy and it's a little offset to one direction like a comet would be. It's still pretty far from the sun right now. This is not water ices that are being gassed out. In fact, in some of the first measurements that have been done, in fact, Laura May, you're on this paper here that's coming out, was just accepted for publication. Yay.
And really the applause is for Bryce.
Yeah.
Bryce led this, and when the person I assist, Bryce Bolin, amazing person who's really specialized in all these, so he didn't sleep for about 35 hours when this object was detected, and that's kind of what happens in astronomy. We had a Keck run the other night, so this was the first paper accepted. It's going to be in monthly notices of the Royal Astronomical Society. And more information to come. But yeah, we had a Keck run the other night, and that thing was zooming so fast.
Yeah.
Even in the images, seeing it on the detector, you could just see how fast it was going. And yeah, pretty remarkable object, pretty different to the other two. So exciting stuff to come.
It's different. So far, it's looking dusty. I was just going to say that.
It's very red, very dusty.
I've looked at some of the papers. I looked at your paper, which is good. And there have been several different papers that have come out, and we're not going to cover them all right now. But you can see here they are.
It's a rush.
These are all in sort of.
It's like a gold rush.
Yeah, these are what's I'll call on the preprint server. So most of these have not been refereed. The one you're on has been accepted for publication now, so it's been refereed. We know that everything is in there and good. We can't trust all of these yet. They need to go through the refereeing process. They'll be accepted for publication. This last one we've landed on was a paper by Avi Loeb. You've probably heard about him. He's constantly bringing up, could this be aliens? Could it be an alien spacecraft? He's already written a paper commenting on it. In fact, we forgot to put the slide in there, Jared, but there's a joke out there going around of how many days has it been since Avi Loeb has claimed aliens? Now it's back to 0 because his paper he's claiming it. So anyway, more to come on this. We'll have a special report on it at an upcoming All Space Considered when Bryce is able to join us.
Absolutely.
Maybe we'll try and see if we could get some other experts to come talk about other things, or at least give maybe a comment from Dave Jewett over at UCLA. He's an expert on these objects too. So we'll get more coming to you on this. It's all hot off the presses. This is stuff that's brand new, so we wanted to mention it tonight. But tune back in a future episode, and we'll get there. So Laura May, you got to go visit the Vera Rubin Observatory.
Yeah, so if you guys paid attention to the news in the past month or so, you might have seen a really awesome headline news. It's not often we get to have astronomical images and astronomical news headline, but you can see it right there, this beautiful image. So we had the very first image unveiled from, and it truly is a revolutionary telescope. So this is from the Vera Rubin telescope. So I'll show you the image just for, honestly, the joy of it. Anyone who's an astrophotographer, Ginger, you probably know this object.
Yes.
This is the Trifid Nebula, so a favorite of astrophotographers, but seen like never before. Honestly, this is an incredible image. So these are the first light images. The telescope is not yet running fully, but they have released these. These are the test images, but the telescope is still in commissioning. And if you're wondering where it is down in Chile. So it's located on Cerro Pachon Ridge in north central Chile. It's about approximately 100 kilometers, 60 miles from the support town of La Serena, where the base facility, the support facility, is located. But even though all of this is done, the observing is done in Chile, this is international, right? These are all international collaborations. In fact, very near to us here in Los Angeles, but up in, I believe they're in San Francisco, is the data facility, SLAC, that built part of the instrument. There's also in Tucson, there is a facility there. There's one also in my country, in France, in Lyon. So there's a lot of data that's going to be coming out of this. They actually might have public alerts within 60 seconds of detecting changes in the sky, right? We're going to get into what exactly it's doing.
Now that's so cool, because if you want to catch the first little hints of a supernova explosion, We usually catch those sometimes hours or days after they explode. Well, this will be able to catch them in those first moments. Somebody that has a run that night on Keck can get this alert, get the telescope on it, and catch unseen features that we've never seen before. So,
can I add too, I spoke with someone on the team for this thing. It's putting out 20 terabytes of data a night, but the camera on this thing is literally the size of a car. It is the largest digital camera we've ever made, and the fact that it reads out at this speed is so far beyond anything I expected.
Oh yeah,
this is amazing.
No, the tech
well,
on it is...
that's what makes this actually our mostest of this month. I
Yes,
think we forgot to
that's
throw
right.
in the
We had to
mostest
throw in the
slide,
slide,
but this is our mostest. It's the biggest camera humans have ever made.
Yep.
How are they transmitting the data? Are they doing it over the internet, or are they going to do it like a sneaker net, where
think
they
it's
actually
staged.
physically carry it?
They ran fiber optic
Yeah,
cables.
fiber optic
Ooh.
cables. Yep.
Look at
so
that.
that is part of the network. And this is the first stone. So originally it was called, you might hear people refer to it as the LSST. So originally it's for its first name, it's still called that sometimes, was the Large Synoptic Survey Telescope. And here's the building itself when I was there. There's this beautiful little halo. And it's kind of an unusual looking building, right? If you've seen telescope domes, even here we have telescope domes. So you'll notice it has this kind of ship shape. And this is very specific intentional architecture. So all of this ventilation, the dome, it's designed to minimize disturbances that can lead to instabilities, right? So those that are caused by non-laminar airflow over surfaces and edge, and that ensures the very smooth flow of air, and that means it minimizes temperature gradients. And the observatory, basically, we want to minimize any instability that could negatively impact the image quality, right? We want the best possible images. That's why it's in Chile. That's why it's on top of these mountains where the air is very, very dry. And these little aprons are also catching the airflow and cooling the building. So a really, really awesome architecture project. This is, some of you might have seen in circulation, the Vera Rubin coin. You can order them actually from the US Mint. So we have an astronomer now commemorated on a quarter in the United States, which I think is super, super cool. Dr. Vera Rubin. Yeah, pretty amazing. So the observatory is named after Dr. Vera Rubin. So she helped prove that dark matter was a thing. She provided the observations for dark matter, for all of our ensuing theories. So a really remarkable astronomer that you got to meet, right?
Yeah, I got to meet her at a meeting once, and we were all in awe of her, of course. But she was so nice, so humble, did not want to necessarily take credit for the idea of dark matter. She took credit for making the measurements and the observations that demonstrated the stars in the outer part of spiral galaxies were moving too fast. She said others came up with the idea of dark matter. She showed that there was a discrepancy. They were moving too fast. There wasn't enough matter there to hold them in place. So she was open to other interpretations, but without her, we wouldn't have known that galaxies had as much dark matter as they do.
Yep.
At least not so soon.
Yep, she had remarkable achievements. And so here is another of the very first images. I forget exactly how many galaxies were in this image. I think it was a couple thousand. Just one of the largest number, you know, when you look at these kind of wide field surveys. And here's an image with labeling that they released as well. Of just, those are a couple of objects, right, that are labeled, of course. There's a couple stars within the Milky Way, and you can just see the absolute expanse and the resolution, right, on this image. When you see them, it's truly remarkable. So I invite you, of course, to go on the website, look up these images, and just dive right into them. Pick a little section. It's pretty impressive.
Although I would say there's more than a couple of stars in these images. There's lots of stars in most of them.
Yes.
You compare it to a Hubble image, these are much wider field. Most of these galaxies are a lot closer to us than the ones you're seeing in a Hubble Deep Field image. However, these are being imaged in resolutions and multiple bands, so we're getting almost spectral information spanning across multiple wavelengths. So it's a data set that we haven't had before. So this is all, it's revolutionary.
Yeah.
It just is.
It really is. And so, in fact, to kind of continue what Dr. Reitzel was saying, if you visited us, which if you're in the room, you have now visited us, congrats, take a look at the big picture that we have downstairs. This was created by Palomar Observatory in Southern California, and it is an example, for example, of these very large images that are created by these kinds of surveys, right? We have telescopes like the James Webb Space Telescope that will look at an object, right? You'll submit a proposal, it'll look at that object, you'll get data. This is a little bit different. It's going to scan the entire sky, and so it can detect those kind of changes like the supernova that you were referencing. And so if you look at the big picture, you'll see there's a comet in it, for example. There are some asteroids. So these are really, really fundamental, important telescopes for astronomy. And in fact, believe it or not, in these first little images that it caught over a couple of days, it detected, so I'll play a video for you to show you what these little circled objects are. Let's see if we can actually play the video. So they released this on the very first images. So we've got a star here, galaxy, and a new asteroid. So in just a couple of nights, it found not just a couple of asteroids, it found 2,104 asteroids, right? And this is in, I think, 3 or 4 nights. So it's going to discover millions of asteroids, which is pretty remarkable because we think we've found all the very large ones. There are regions that are harder to investigate. But this is really, it's a discovery machine, as they call it, the Vera Rubin Observatory. So it's going to find all of these, and it can detect up to 10 million changes in the sky per night. Asteroids, supernova, perhaps other interstellar visitors. And if you're wondering how all this was made possible, well, you may have played a part. Anyone here ever used Microsoft Word or Excel?
Unfortunately, I remember
Excel.
Everyone raises their hand, right?
Excel.
So anyone remember, of course, our friend Clippy? Well, congrats if you got mad at Clippy one day. You contributed to the creation of this telescope because Charles Simoni, who led the development of Microsoft Word and Excel, he donated $20 million for the building of the telescope's mirrors, which is remarkable. He's also donating, I think, $1 million per year to support early career scientists who are using the data, which is really, honestly, super generous and just wonderful.
Do they get free paper clips?
I hope so. I hope they get a free trial. Maybe they get free versions of Word and Excel. And so here is an image I shot of this incredible telescope, right? So it operates on what's called an automated cadence, and it surveys the entire visible sky every few nights, right? So that is remarkable. And the reason, one of the reasons it can do this, so here's a wonderful video from a friend of mine who was there a few days before, Theophanis Mantzopoulos. He's a planetarium film creator, created this incredible film showing the telescope moving. The camera is slewing, that's what we use as a term in astronomy, and you just see how smooth it is. It's so fast, so smooth, and that's part of the reason that technology allows it to do this so quickly, right? It's honestly kind of hypnotizing when you get to see it. And the mirror is also a very unique 3-mirror design, which you can see here, the pathway of the light, right? So it creates this exceptionally wide field of view, and the weight of the mirrors, by the way, is about 35,000 pounds, 16,000 kilograms. So pretty large, pretty hefty. This is if you wanted a human comparison. Little tiny person next to this giant camera, and so it was built by the Department of Energy, SLAC, and yeah, as you said, largest digital camera ever constructed for astronomy, roughly the size of a small car, and weighs over 3 tons. So the focal plane. For the nerdy people among you, it's 189 charge-coupled device for a combined 3.2 gigapixel camera. So a little larger than our DSLR, I think. Just a wee bit.
I actually asked in an interview, like if I was trying to project this image at full resolution on a bunch of screens, like how many screens would it take? It was over 400.
Wow.
One of these images would literally cover the size of a building.
I think we need a new big picture. I feel like we should have a second one, and we should expand Griffith Observatory. So here's the field of view, right? So this is about 3.5 degrees or 9.6 degrees square, and it's more than 40 times the size of the full moon, right? So again, it's shooting these enormous parts of the sky at very high resolution. So very impressive. And this is just to give you an example. So this is a drawing. This is an artist illustration. But this is to give you an example of how deep it can go. The more light we get, again, this higher sensitivity, where we could only see a couple of galaxies, now we're seeing stuff that's really, really far away, these faraway galaxies. So pretty impressive stuff. And here is the control room. So they were working on, they were showing us, they were refining the active optics when they were there. So of course there is, a lot is done because we're we're on Earth, we are observing from Earth. So unlike telescopes like the James Webb or the Hubble, we have an atmosphere between us and the stars. And so we have to do some corrections on the mirrors in order to get these incredible images. But of course, it's not just them also working on this. Lots and lots of support telescopes will be working on it. This is the Blanco telescope, which I also got to work at and visit. And it is actually the oldest professional telescope in Chile. It was the first one set up. And it's also the most productive. And the way they measure that is by number of papers, research that has been made through this telescope, through the observations. And when we were there, they were observing, I believe, the something in the galactic core, I think Omega Centauri, and also had a Nobel Prize from some of the research conducted there. So these telescopes are not spoken about as much. It's not going to be in the articles, you know, about the Rubin, but they're super, super important. They need funding, and they are really important to support everything that's happening there. And one of the other things that the Vera Rubin Observatory is doing, it's actually the first time that education is going to be part of what they consider to be the deliverables. So you can go on the website and you can learn all about it. They've created so much content for people who are interested in these telescopes because, of course, all of this could not be possible without public funding, right? The NSF, Noir Labs, so many groups give money to this, and of course all of this is funded, and so it's very, very important. And there's going to be some involvement that we will require of you, believe it or not. Anyone here ever heard of citizen science like Galaxy Zoo? Really, really fun projects.
A few people.
Yep. You could go on there and classify galaxies. I feel like this was 10, 15, 20 years ago. I remember logging onto this. And so they're going to make up to about 100 citizen projects in the first couple of years that are going to be hosted, I think, in part by the people who made that Galaxy Zoo. So you can connect on there and classify, I think, look through images, classify things. You get mentioned in papers, by the way, sometimes. So when you make discoveries, you get to be part of the science that's being done. And you know, the staff there, this was a nice little, I caught this lady's wonderful little nails manicure matching the Vera Rubin, which was a nice touch. A lot of really fun people working there, a lot of wonderful people. And yes, and this, by the way, my trip was funded by also the NSF. Unfortunately, there's no more funding for this next year. So I hope people out there, if you feel inclined to fund science, to bring more. I was with a wonderful group of people, and we'll talk more about Chile in another episode, but wonderful ACEAP cohort that brought me there. So.
Yeah, well, I wanted to ask you, how did you get this trip? It was through the NSF, but how did you apply? What was the program?
So I applied for this program. It's the ACEAP Astronomy Ambassadors for Chile program, and got to go with about 10 other people to Chile, visited all the sites. So in another episode, we'll talk about ALMA, we'll talk about my favorite, one of the solar telescopes, which everyone was kind of confused as to why I cared so much about this tiny little container. Someone in the audience understands, and I was messaging him while there because I was very excited. But yeah, so the goal is to promote you know, the astronomy that's happening in Chile because it's extraordinary, and it is now something in the next 10 years we're going to have 80% of astronomy is going to come out of these sites in Chile. They have done, I think, a wonderful job of working with also local people in Chile and really having astronomy provide opportunities and be embedded in society. People are really into science, really into astronomy. They're really proud of the fact that now the universe is going to be seen through the eyes of Chile, which I think is pretty remarkable. So more on that at another time. But yeah, really, you can apply to this program, by the way. You know, there's lots of different people who do it. There's some astrophotographers, top people, some other astronomers, teachers. So, you know, give it a shot, apply, and go to Chile and discover all these amazing places.
I just think it's so great that you're sharing this with us. We're lucky to have you on our show, someone that was actually down there. I'm a little jealous, but anyway, it's just fantastic, and we'll return to this in the future for sure. And by the way, folks in the audience here, if you have questions, feel free to raise your hands. We'll answer questions on the fly if we notice you. Of course, we'll try to. Well, Jared, we're going to return to you with an out to launch. Last month, we had our own failure. with
Yes.
of a sort of failure showing a failure.
Anomalies
So-
on anomalies on anomalies.
Yeah, it was a
let me
little
tell you.
recursive, but let's see how it works tonight.
Just a little bit. All right. So if you have been living under a rock or perhaps a piece of shrapnel, you may not have known that SpaceX is developing their Starship rocket. They had a little bit of an issue with Ship 36 about a month ago. So let's take a look at the issue that happened. Oops.
Oh my!
Whoa!
Okay.
Straightforward issue.
No!
Yeah.
Oh.
So I don't think you have to be a rocket scientist like me to know that that's a bad thing. So typically the fire doesn't go up like that.
Oh.
It's supposed to go down.
Oh my God.
And it's usually contained
It
much
appears
better.
there's
Ship
been a
36
as
just
well.
blew
But
up.
this was during
Ship
the
36
static
just blew
fire
up.
attempt where they were going to be testing the engines
It just blew up.
and the vehicle overall. And as you
So
can
about
see,
those
there was
launch dates, I
something
think that
went
may
wrong.
delay a bit, as
Pretty
we've just
much
experienced a
destroyed the test
run
site,
of Ship 36
and
prior
they
to
are
a
on
planned
the road
static
to
fire
recovery.
test
And
at
this
the
was at
NASA's
11 at
test
night.
site in
Yes.
Starbase,
How loud
Texas.
was the boom for the people that live nearby?
Probably significant.
Probably significant, yeah.
So, yeah.
Where was this?
So this was at Starbase in Texas.
Texas, yeah.
So at their site that they
No.
have there. So the leading cause of what it could be right now is a composite overwrap pressure vessel, or basically these vessels that are wrapped in composites, and then you put gases and other things, like in this case, I think it was a helium one that they used to pressurize the tanks with. It might have let go. It overpressurized the tank, which caused the tank to rupture. And then, if you get methane or liquid oxygen together at the same time where they're not supposed to be, they have an energetic event like that, to say the least. So there's debris everywhere. There's some pieces actually flew far enough that it went over the border and into Mexico.
I heard they weren't happy over there.
And everyone was saying, "Oh, look, Starship's made its first international flight." But obviously, to everybody at SpaceX, good luck to you guys. It's if this was easy, everybody would be doing it.
Yeah. How much time before we'll be able to see another test? This has got to be a setback.
Man, so obviously there are aspirations amongst certain individuals within the company, and then there's also people outside who just kind of understand these things. And a lot of us are looking at mid to late August as the earliest that they can. So basically about 2 months of a setback from this here.
Okay.
Basically had to rebuild their test site, and also when they were cleaning up their test site, they had a crane accident as well. They had a crane that was there and it tipped over and fell, and then they had to clean that up on top of their accident.
Okay.
So it's
Well, at least we have the SLS program. That's
nothing could
that.
possibly go wrong. In fact, they were testing.
That's a little foreshadowing for you folks.
They're testing something called BOLI, which is a solid rocket booster. It's going to be used from Artemis 9 and onwards, if we get to Artemis 9 and onwards. And it's called the Booster Obsolescence Lifespan Extension. And it also had an anomaly with its nozzle during testing. This is in very, very, very slow motion here.
Well, that's not good.
Yeah, the gas is coming out of the nozzle, not all that great. And then we're going to have a little bit of backup in pressure, and that will take care of the nozzle shortly. It's not great.
Oh,
Yeah. Who needs nozzles?
now, if something like this happened when it was attached to the rocket itself and was going up, how bad would that be?
So this would not be great, to say the least. Especially with the second one here. There has been no official word from anyone involved in this, whether it be it NASA or Northrop Grumman, who's building the solid motors for the Space Launch System, as to whether this would have led to a loss of LOC or loss of control,
Right.
or LOV, loss of vehicle event. Obviously not good, but this is why you test, right?
Yeah.
This is why they test Starship, to make sure that they happen on the ground and not in flight. This is just a tool called a CO2 quench arm, where they send an arm that's spewing carbon dioxide out of it down into the nozzle to basically kill the combustion, and then they will actually take this booster and open it up and inspect it, and take a look at every little detail that they
Now,
possibly
what's
can.
the diameter of that nozzle?
Oh my
What's
gosh!
the size of that?
I want to
Roughly.
say probably 2.5 to 3 meters in size. So
Yeah.
I could walk into it very
Okay.
easily. So
Yeah,
it's
big.
pretty big. And then just before and after, with it there, so you could see. Before, it's very nice, pristine as it should. After, where's the nozzle?
Yeah.
So, and then also, whoops.
Yeah, a little brush fire.
Yeah, but also it's expected that happens. Again, these are really big rockets that they're testing. 4 million pounds of thrust is how much the solid is making. And of course, big shout out to NASA Spaceflight for both the Starship video and this video as well, doing great coverage work with that.
So how common is something like this that happens?
Oh, a nozzle? Letting go? Well, Northrop Grumman was testing their solid rocket motor for their Omega booster, and it lost its nozzle, and they said there was an observation, right? An observation that they had. Not an anomaly, it was an observation.
Okay.
And then last year, United Launch Alliance on their Vulcan rocket, which we actually did talk about it in the November out to launch, I believe, they actually had a nozzle let go on that flight, and the rocket was able to continue. So
I feel like there's a T-shirt design in here somewhere.
Yeah.
Don't let go of your nozzle, or
like hot nozzle summer
yeah,
or something.
something.
I don't know.
I don't know. You got ideas? Send them in to us,
That's
folks.
right.
Yeah.
We'll make t-shirts.
So now there was another flight that we want to cover.
Yes, Axiom 4, which was a great flight by all the measures. So some success to talk about here. And Axiom Space is a private company, and they actually are flying this specific Crew Dragon capsule from SpaceX, which is the final one, which the commander, Peggy Whitson, named Grace. This is Crew Dragon Grace. And carrying 4 astronauts, Peggy Whitson, the American commander, on board. She's an ex-NASA astronaut who's now a private spacecraft commander for Axiom Space. And she is essentially, at this point, the most, she has...
We can see now crew looking to make, the first crew members looking to make their egress from
so, as they said,
spacecraft along that slide.
Sliding out.
So it was really cool because of the astronaut.
And there she is. We see Commander Peggy Whitson.
Are these spacesuits exhibited anywhere? Because I always see in museums, the standard NASA ones, and I've never seen one of these.
I don't think so. These are the SpaceX IVA, or intravehicle activity suits, because they're
And
still
we've got our
brand new,
pilot,
actually probably
Shubhanshu Shukla.
from India, by the way, also carrying an astronaut from Poland and Hungary on this flight as well.
Okay.
So very, very exciting that Axiom Space is sort of opening up access to the International Space Station for truly an international group of astronauts. So.
Yeah, a lot of fun. Well, thank you for that report.
Yeah.
I'm glad we were able to turn that. Yeah, thank you, everybody. But Ginger, we've got some beautiful pictures to show off tonight.
All right, let's get to it.
Yeah.
Okay, so who's a fan of cats in here? Cat people, raise your hands. Okay, wonderful.
like a cat.
So we have some fantastic images from the James Webb Telescope this month. They actually released this Cat Paw Nebula for their 3rd year anniversary.
Oh.
Yeah.
Oh, nice.
Got a lot of really great detail in this photo. And let's see, this is located about 4,000 light years away in the constellation Scorpius. So pretty neat photo.
And in an amateur scope, it looks a little like a cat paw.
Yeah, like a
It's
little,
got those
go
little,
back to it.
Yeah, the little glowing
Those are
regions.
little
in
beans.
it.
The little, that has the little
Beans.
toe beans,
Yeah.
right?
Cats in space.
All right, and then we have another release. This was on June 30th. This is the Bullet Cluster found in the Carina constellation, about 3.8 billion light years away. And it's a cosmic collision between 2 massive galaxy clusters. You can kind of see to the left and to the right. In this next image, we'll see a little bit more of the near infrared light that we see. So those super hot regions in the pink and then the blue ultraviolet.
Yeah. What's cool about this one, I think you wanted to say something too.
Yeah, I think
We'd fight for it.
We fight.
These 2 clusters passed through one another. The galaxies on the left and the right, they kind of swap places. The red stuff in the middle is actually the hot X-ray gas. Clusters have this hot inner cluster or intergalactic gas between the galaxies. Well, it ran into itself and got stuck in the middle, and the galaxies continued on their way. Now, Laura May, why don't you tell us what the blue is?
Yeah, and so this is actually one of the best proofs of dark matter, believe it or not. So it ties back to Vera Rubin. And again, as you mentioned, because of the way there was this collision and the way the gas moved, is a, I struggle to explain how exactly the...
Well, it's ram pressure. It's like if you have I don't know, if you had, say, a sparkler in your hand, as you move along, the smoke from the sparkler gets left behind as you wave your hand around. So in this, as the galaxies pass through one another, that gas that was in the cluster got left in the middle when it ran into itself. Turns out most of the mass in a cluster like this is in that gas.
Yep.
Most of the mass is right there. So why did the dark matter travel with the galaxies?
Sorry?
Why did the dark matter travel with the galaxies?
And it's static. I mean,
okay.
I think
it's probably because it's particles, probably.
Exactly.
Yeah.
So the particles traveled with the galaxies. They just passed right through with one another, didn't notice they were even there, and the gas got stuck in the middle. This is evidence against modified gravity. If you've heard people try and explain dark matter by saying, well, maybe gravity just gets stronger as you get further away, or it just gets weaker. I guess it would have to get stronger to make things swing around more.
Yeah.
So maybe there's this distant thing. As you get further and further away, it doesn't drop off quite as fast. Well, this is evidence against that. The matter, the dark matter, should have been stuck around that pink gas, and it's not. It traveled with the galaxies, so it's probably something like a particle.
Yep. Further observations, hopefully one day.
Exactly.
We'll
So we're
see.
throwing some science at you in the middle of our pretty pictures.
I had to.
We had to. It's a beautiful picture, too.
Important
All
object.
right. Okay, we got our lunar image from our very own David Pinsky.
Pinsky. Yes.
This was taken at the public star party on July 5th, which, if you don't know, once a month we have our public star party here at the observatory. It's super fun. Come check it out. We have all the telescopes out on the lawn. It's a very fun thing.
Yeah.
And then another one, this is a solar image taken with a Lunt 50 solar telescope and a Canon 60 MK2. So a little bit of astrophotometry.
That is a crazy prominence there. I don't know,
Yes,
folks, if you know the
it's
loop
amazing.
that's in the upper right corner about 2 o'clock.
That's at least a dozen times
That's crazy.
in width the size of the Earth, and probably 6 or 7 times in height. So really remarkable.
I think it erupted the next day.
Yeah. Just an amazing photograph, David.
All right, going to the next one, we have astronomy picture of the day. This was July 13th. I picked this one because it's summer, and I don't know if anybody else has an ant problem.
That's
why you get ants.
Didn't know there was an
So
ant nebula.
And now they're in space even.
I know, it was like they're everywhere. I can't keep up. So this is the Planetary Nebula, Ant Nebula, being cast off by a star similar to the sun. I just thought this was pretty cool. It does actually look like an ant too. And this is in the constellation Norma, which is a southern constellation, which you probably know all about now, being in Chile.
I know all of them now.
Yes. And then this next one is super special. This is astronomy picture of the day for today, July 17th. How perfect is the Rosette Nebula, which was actually taken down in Chile at the observatory.
At the Blanco.
At the Blanco,
that we
yes,
showed earlier.
exactly.
The longest running,
Yeah.
the first observatory.
And this,
there.
I mean, the detail in this, it's incredible. And the colors are just absolutely beautiful.
Yeah, the color hasn't been added here. What they've done is they've taken the image in multiple filters, and then they assign the red color band to one filter, the blue to another, and green to a last one. So it's sort of RGB, just like your TV works or your computer monitor.
Right, yeah.
So, but the colors have probably been picked to make this most spectacular.
Yeah.
But that's okay. Again, your eye wouldn't be able to pick this up anyway. Even if you were there, your eye is too small to see these colors. It would be a very faint glow, perhaps.
Yeah, we see mostly in black and white at night. I don't know if you've ever noticed, but it's once you know it, you're like, oh, yeah. Can't really see colors.
I know with like getting this with like a smaller, like a DSLR camera and a lens, you get a lot of that hydrogen. You can pick that up.
Yeah, the pink is probably coated, just like you said, to the glowing hydrogen gas. It glows at a wavelength that's sort of that pinkish red. Our very own spectrohelioscope here at Griffith Observatory can show you the sun in that same glowing wavelength of hydrogen.
Okay, and then another one, a Milky Way shot from Cerro Tololo. Do you want to go ahead and talk about this?
This is an image I shot, so about 10 days ago, from just outside, in fact, not too far, just down the hill from the Blanco Observatory that I showed you guys, just in front of my room where I was staying. So late into the night, shot this image of the galaxy, and of course the sky there, as you can imagine, is absolutely incredible.
This is just
a little bit edited. So
one shot? Just one shot?
This is one shot.
Okay.
I did not stack or anything like this. It's really the heart of the Milky Way. And the colors, you know, some of those colors are, I edited this just a little bit, But this is roughly the colors that it has, and what you're seeing when you have a really, really good sky, which is why we want to protect our skies and have better dark skies. Imagine if we could see this every night in Los Angeles. And that's not that hard to do. But yeah, really, I was amazed that I was able to shoot this just on a DSLR with a lens, and you know, tried my luck and got a couple of good shots. Maybe another time I'll have to show the Magellanic Clouds, which are really remarkable.
Oh
but
my
Milky
gosh.
Way is always a classic, and you can really see also the color. That was the only change I made, is I upped the saturation just a tad so you can see the colors of the stars, all those blue stars, this kind of reddish. It's really cool once you get to notice that in the sky.
What was your exposure time on this one?
This
Out
was
of
only
curiosity.
about 20 seconds, I think, 25
Yeah,
seconds
that's
tops,
really
because you know, as soon as you do any longer, you've got star trails. So
Right,
this is
right.
without a tracker.
Okay.
And yeah, you can get skies like that from with just a camera. So
I'm jealous of those dark skies.
right.
DSL that are we talking? Because I mean that looks amazing.
That's a Nikon DSLR. I shot it on a. I'm trying to remember. That might have been my fisheye. I shoot a lot of fisheye stuff, so I'll get a little more grain, but I can get kind of the whole expanse of the Milky Way. Or I might have shot it on a 24-120 lens, but you know, just pretty standard DSLR equipment. Yeah.
Fantastic.
Yeah.
Just to show you a little bit of contrast from the dark skies, here we have a Milky Way shot. This is up by Lake Cachuma, so up above Santa Barbara. You can see a little bit of light dome, of course, from Santa Barbara, from the city. But
Still cool that we
nice
get to see this in California.
Yeah.
Yeah, you can still get away.
Yeah,
Still
if you
see
head
the
to
Milky Way.
head to the hills, head to the Sierras, or head out, you can start to pick it up. But anyway, Joshua Tree
Yeah.
is starting to get a little bit of light from everything, but you can still see the Milky Way.
The west side of the U.S., though, is still much better than the east side.
Oh,
the
much
east
better.
side, my gosh, you've got nowhere. But on the west side, we've got quite a lot of opportunities to go see skies like that. So I'm trying to get to a dark sky.
Yep.
Don't get me started on light pollution.
No, we'll talk about that as well in an upcoming episode. Well, thank you for that, Ginger.
Yeah,
some
thank you.
some beautiful images this month. Well, now, Sarah, it's so great to have you back, but you're now at Planetary Radio with the Planetary Society. So why don't you take it over here a little bit and tell us some about what you do there?
Yeah,
what
well,
goes on at the Planetary Society?
I mean, first off, I want to say thank you so much for having me back. This is a really trippy moment for me. I worked on this show for almost 6 years as a show producer, so being asked to come back as a guest is really a highlight for me,
Well,
and I'm thank you so much for bringing me
Well,
here.
thank you for coming. It's our pleasure.
But as you said, I am now the host of Planetary Radio. It's a weekly podcast put out by the Planetary Society, which I'll talk a little bit more about in a moment. But basically, I interview people who work on the science, or who talk about science or share it with the world. So leaders of missions, people making movies about space, people who are having space experiences. Every week on Wednesday at 8 a.m. Pacific time, we put out a new show. And then twice a month for people who want to get really deep into other topics. We have one that is space policy only. That's on the first Friday of every month. We do a deep dive into what's going on politically with space so that you can know what's happening to be a better space advocate. And actually, starting tomorrow, we're doing a new show. It's our Planetary Radio Book Club edition, where we interview people who write books about space. So, first one coming out tomorrow is going to be with Andy Weir, the guy who wrote The Martian.
Oh, okay.
Yeah, so we'll be talking about his book, Project Hail
Hail
Mary,
Mary.
since they're coming out with a movie about that.
Yeah,
But
that's a fun book.
I'm having the best time ever just talking to people about it. It's such a privilege to be able to have access to scientists around the world to talk about their work. I wanted to share this because I have an image online that I share, and yes, I do wear the cat ear headphones when I'm doing interviews. It's a real thing. But I wanted to ask, who did this artwork of me? Because I look diabolical and I love it.
It was our museum guide, Ian. Are you in the audience?
I don't think he's here,
I don't think he's here
Ian
tonight.
Cravella.
Dude, personal thank you from me to you. I am framing this on my wall.
Yeah, we can get you various
You look
versions.
like a cat. I feel like there's
Yeah.
a little cat paw. But I can see the diabolical, yeah.
Just a little bit. Yeah.
Cats are a little diabolical.
Exactly.
But Planetary Radio is a podcast that's produced by the Planetary Society. So we are the world's largest and most effective nonprofit that's dedicated to advancing space science and exploration. And that takes many forms. So it could be outreach and education. It could be doing political advocacy work. We have members all around the world, and we've been doing this for 45 years. Right now we're celebrating our 45th anniversary. Ooh. So it's... it's a wonderful organization full of truly the best humans I've ever met in my life. And together, with the work that we've done educating people and advocating for space, we've actually done a lot of work to help save missions and get some missions actually being made over the years.
Who started Planetary Society?
Oh, well, some people may be a fan of this guy, Carl Sagan. Is anyone familiar with Carl Sagan?
Yeah.
So Carl Sagan, for those who aren't familiar or might be younger, Carl Sagan was a very renowned astronomer back in the day who's very famous for doing a television show called Cosmos. Now, I loved Cosmos when I was a kid. It was actually part of the way that my father learned English. We would watch Cosmos together all the time. I loved this show. But Carl Sagan was joined by his colleagues, Bruce Murray and Lou Friedman, and together the three of them formed this society. And the reason they did it was because, those of you who are familiar with the Apollo era, there was a time when we were funding space exploration so much that we literally sent people to the moon. But shortly after that, a lot of that funding was scaled back. And in that time, the US Congress was in a moment of not wanting to continue on with that funding. They got together and they said, no, we are convinced that there are people all around the world who love space so much, they want to do something about it. We are going to create this organization to give people a grassroots way to advocate to their governments, not just in the United States, but around the world, so that they can share their love of space. Now our organization is run by this guy. You might know, Bill Nye, the science guy.
Hey, Bill Nye.
Yeah. I love this guy. He was one of my heroes when I was a kid. He's now our CEO. This is a picture of me, my brother, and Bill at the last eclipse. We were at our Eclipse-orama event in Fredericksburg, Texas. This was such a fun time. But Bill is helping carry on that legacy, and our group together has been continuing on this work for a while. But, as we said before, I got my start here at Griffith Observatory.
Hey.
I got my degree in astrophysics, and after getting out of school, I realized that even though I loved doing the research, what I really loved most in life was talking to people about all these amazing things we're discovering. The scientists are doing so much amazing work, but communicating that to people and seeing the spark of recognition in their eyes, like the first time you tell a kid that they're made out of stardust.
Really?
Those are the moments that I live for. So I ended up working here. Oh, hold on. We've got a software,
not up there, though.
software
We're all
update.
right.
It's trying to push through.
Do we need to
It's only on our screen,
put
don't worry.
cancel? That's, there we go.
Yeah, thanks, Mac.
There we go. Thank you. But I want to throw back to this moment in 2019. Some of you, I think, were actually here at the time. I know you were. This was a moment when Matt Kaplan, who was the previous host of Planetary Radio, was here in this theater. He was the guest for that show, and he was here to talk about the LightSail 2 mission, which was our mission that we launched. We had 50,000 people around the world help crowdfund this mission. It was the first fully crowdfunded space mission in history, and it was a solar sail. Essentially, we were using the light of the sun as a means of propulsion for a small spacecraft. We wanted to prove that was a viable means of propulsion so that other missions could go forward and do that. And since we proved that, now there are other missions that are going forward with that. I do want to say, though, all props to the Japanese Space Agency for accomplishing it first. But the LightSail mission was a really special moment, and I met Matt Kaplan here. And in that moment, I asked him more about the Planetary Society, and I asked him, how do I work there someday? How do I do what you do? And he remembered me. And years later, when I applied to work at the Planetary Society, he vouched for me. And I got a job working in social media there, and ultimately applied to his job when he decided to retire from Planetary Radio. And Matt Kaplan, if you ever get a chance to listen to his previous episodes, and he did the show for 20 years. He is an absolute legend. He knows everything, and he's one of the kindest humans I've ever met. And I want to say I'm really happy for him because he recently got to go on his first zero-G flight.
Aww.
So that was a lot of
That's
fun.
fun.
Nice.
Got to share that on the show this week. But now I just interview people all day long. Here is an image of me interviewing Don Bacon. He's a representative from Nebraska. He's one of the co-chairs of the Planetary Science Caucus. Part of what we have done is to advocate for the recreation of the Planetary Science Caucus. It has to be recreated every 2 years, and it needs to have bipartisan support. So him and Judy Chu, our representative from Pasadena, both co-chaired this, and now we have a bunch of different members that are working in Congress to try to advocate for space and to learn more about it. And anyone in Congress, even their staffers, they can come to the things that we set up. My job isn't primarily advocacy, but I want to share this with you because we're in a really interesting time right now where a lot of NASA's funding is on the line. And part of what we do is mobilize people like you. No matter your level of understanding, we're all here because we love space, right? Because space is amazing. And we want people to fund it. We want to be able to go out and make these discoveries, and it truly doesn't take that much money to do so when you look at it on the scale of things. So every year, we take a group of people to Washington, D.C., volunteers from across the United States who all come out with us. We give everyone training on how to advocate straight to their Congress people, and we set up a full day of going around Congress to talk to them face to face.
That's awesome.
Yeah.
I know, right?
Wow.
But, honestly, the applause should go to the people in this image because they fly out on their own dime. They come with all that love and that passion, and they advocate with us, and they march all around D.C., and it is not an easy thing to accomplish. And I know I was a little scared the first time that I did it, right? Because I'm an astrophysicist, man. Like, I didn't go into politics, right? But I've learned enough to be able to advocate for it, and with the help of our space policy team and everybody that I work with, I was able to do this effectively, and now I get to go every year. But the reason right now is the time I want to talk about this is because of this graph right here. And I know in past months you guys have gone through all of our graphics to learn more about this, so I won't belabor the point. But this is a graph that shows the funding for NASA over time. And you see that giant jump on the left-hand side of this? That is the Apollo program. That is the funding that took us to the moon. That is the reason why we had people walking around up there. But over time, that funding has waxed and waned. But down there at the bottom, on the bottom right, that line right there, that is the current presidential budget proposal for NASA. It takes about 1/4 of all NASA funding away. But when it comes to planetary science, which is something clearly Planetary Society is very passionate about, it takes about 47% of the funding away. That means the cancellation of over 40 missions. Missions that are either in progress of being made, missions that are already out there, ones that you may know and love. Juno, Nancy Grace Roman. If you love Pluto, we just had the 10-year anniversary of the flyby of Pluto. The New Horizons mission is also on the cancellation block.
Yeah.
The Voyagers, even the SLS program, the program that's going to take us to the moon next, the SLS, the rocket, and Orion, the capsule. Everything after Artemis 3, so all of those beautiful missions planned to send people from around the world back to the moon, all of that is at stake right now. But we're going to do our best, and I'm going to give you a few updates that have happened in the last week or so. First off, we do not have an acting NASA administrator right now. We were going to have someone there. His name was Jared Isaacman. He was going through the nomination process, but he is not going to be the next NASA administrator. Instead, we had Janet Petro as the acting NASA administrator, and as of just recently, it is now being transferred to the Secretary of Transportation, Sean Duffy. Essentially, this is going to be the first time in NASA history that the organization is going to be run by someone from a different department. And it's just a temporary situation. But because we're in this really difficult situation with the funding, it would be really wonderful to have solid NASA leadership in this moment. But there's good news, all right? Because of all this advocacy work that people have been doing, and the 75,000 letters that people have written Congress, and we have people from over 100 nations who have signed in on our petitions, and all of the other science organizations, the AGU, the NSF, all these different groups are joining this cause. And together, we've actually gotten through to them. And I think something really key to point out about this is that space science is something that brings us together across all walks of life. It doesn't matter what political part of the spectrum you're on, and that is true in Congress as well. No matter who you talk to, everybody loves space. So it's really easy to have a good moment talking with them because you're not coming in from a place of contention. You're coming in from a place of, check out this cool image. We want to go to Venus. Like that is a much easier place to come by. So if you're looking for an easy point of entry to learn how to communicate to people politically, this is a good place. But what we've seen in the last week is both of the appropriations committees for both the Senate and the House of Representatives have taken this up, and both of them have rejected these cuts to NASA. Although I will say, the one in the House, something else got added to this situation right before it was going to pass. So that is actually going to be going back in for discussion. Well, it was this morning, actually. Yeah, it was this morning. So tomorrow morning, I'm going to be getting an update on how this worked out. But if I go back one, the Senate, the House of Representatives did pass theirs through, but it does still include a cut to NASA, right? But what we're seeing here, even though it's not ideal, what we're seeing here is that both parts of government, outside of the executive branch, I guess just let's go with the Senate and the House. Both of them want to make sure that NASA is funded. It's just a little complicated. So right now is the exact time when we need to be as loud as possible about this. And it's really easy to do so. If you want to learn a little more about how to do this, if you become a member of the Planetary Society, we offer an online course called Space Advocacy 101, where our space policy team takes you through how to advocate for these things. And it's actually quite easy. And it's a really fun course. And all praise to Casey Dreyer and Jack Corelli, our space policy team. They're absolutely fantastic. And if you want to learn more, you could go to our website at planetary.org/save-NASA-science or save-NASA-science. We have all the things that you can do in order to help us with this situation. And if you would like, you can listen to my show each week. We give updates on what's going on there.
Well, I recommend people listen to your show just for the fun astronomy and science and the interviews.
Honestly, it is so cool. Next week, we're going to have on Alan Stern and Nadine Denton talking about the Pluto flyby. The week after that, we're going to be talking about sleep science and space. Have you ever been curious about how...
Everybody count the number of times Alan calls Pluto a planet.
I mean, he didn't actually both planeted and dwarf planeted. And
did he? Okay.
He did.
He's coming around. Because I think that being the king of the dwarfs is pretty cool.
Yeah, honestly. Pluto, so. And the Pluto system is absolutely wild. But that New Horizons mission did so much more than just fly by Pluto. Yeah. The flyby of Arrokoth, what it's doing, learning about how our sun and all the material in our solar system interacts with the interstellar medium. There's a lot of science that's happening there because that thing is so far out there that it's the only spacecraft that can do that kind of science.
Yeah, so. It's interesting. Yeah. Well, thank you for the update there. Well, folks, let's give Sarah a round of applause for her work on planetary science. Well, when I invited you to the show, one of the conditions was that you were going to help us out with this next segment.
Absolutely.
Astro-Lotería. Now, folks, you might be a little confused here. Why do I have bingo balls floating in front of a loteria? What's going on here? Well, Bill's going to help us out here. Bill, why don't you stand up and take a bow? Yeah, exactly. Bill Greenberg, everybody. What's going to happen here is Bill's got a bingo dispenser over there, and he's going to pick a bingo ball. That's going to determine which of these stories we're going to tell. So that's the only connection to the bingo ball. Then after the end of the story, we will reveal 3 cards. Those cards are the Loteria cards. So those are the ones that you'll fill out on your cards that you have here in the audience. You can put a check mark next to it. And if you get any row, column, or diagonal, you've won. So 3 things will be announced. We expect some winners really quickly, probably within 2 or 3 stories. We'll have some winners. We've got, what do we have to hand out, Bill? What do we have?
You're talking about gifts?
Yeah, what sort of gifts do we have? What sort of prizes? Although, Laura May, are you giving away the...
So I will give away a Rubin Observatory coin. So I suggest you play. This has been inside the Rubin Observatory.
Yeah.
I had a little bag of them that I handed out to the staff. So this one is up for grabs tonight for a very special winner.
Don't spend it.
Well, it'll be the
Don't
first.
spend it all I want. Don't spend it. Frame it.
The first person to yell. What do you yell when you win Loteria? Loteria, that's what I thought. So the first person to yell Loteria, well, that's what I thought. But anyway, I'm the gringo here. I've played it before with my friends. But yeah, so yell Loteria when you win, and if you want the coin, the first person to yell it out will get it. Now, if 2 of you win it at first, the first person to yell out, because But we only, anyway, you'll
Don't
see.
lie.
Don't
okay?
lie.
We'll check.
Don't lie, everybody.
We have any calendars?
Yeah, do we have any old calendars to hand out this time, Bill?
We do not have any reference.
I think you've got a microphone over there, Bill.
Do I need a mic?
No, you have a handheld over there.
Oh, I
somewhere.
do? Oh, where'd it go? Oh, there it is.
If you're sad about not winning one of these, by the way, you can get them on the U.S. Mint website. So get your nice astronomy Vera Rubin coins.
Yeah.
So you mentioned about the funding, and what portion of the funding is from the government? Is there any like private party or even civilian like us that could be donating fund? What are like some of the portions? Because I have my student, we have about 3 dozen of students here. Want to give them some ideas like what funding and fundraise ideas they could do.
Absolutely, yeah. So just to restate the question in case anyone didn't hear, basically what portion of the funding am I talking about comes from the government and what comes from public funding and ways that people can donate? What I'm talking about here is specifically just government funding for NASA. So we're not talking about any private donations or anything. NASA, in this case, is just taking the money straight from the federal government. So this is the bulk of everything that funds NASA. And it's not just NASA that's at stake right now. It's also NSF, the National Science Foundation, a bunch of other related things in science that are being funded right now are also being cut. So there are still ways that people can personally help to fund things. I think like the Vera Rubin telescope also has some private funding as well,
Sure.
right?
Yeah.
Yeah,
But
and
in
like-
this case, we're talking strictly NASA money from the government.
Yeah, and some of the largest observatories being built on Earth right now, the 30-meter telescope, the extremely large telescope the Europeans are building, that has a lot of private funding in them, but there's still some government funding in those as well. So it's kind of complicated, but for big projects, things like if we ever want to have people walking on Mars, well, that's a really big thing to do, and having a government behind it makes it possible. Having a private company behind it, SpaceX wants to do it, but notice they're leaning more into doing it with government even these days. So it's complicated, but the way to really help out is go to the Planetary Society, check out those advocacy tools they have there, and join in with them if you care about space and science. That's the best way you can help right now. So, yeah. So, Bill, what do we've got for prizes?
First of all, can everybody hear me?
Yeah.
Okay. We have, well, this is just the classic prize, NASA stickers.
Yay!
Don't stick anything in our building. We're
Yeah, take
usually
them
we
home.
don't give stickers
Oh, that's right,
because
Take them
don't
home,
put them in our
on
building.
your
That's a
laptop
nice pack of
cover or something.
meatballs.
Yeah.
I really like this one. This is actually a very useful ruler on one side. On the other side, it has the TRAPPIST-1 system. This is a
Exoplanets.
really important system of exoplanets
Yeah.
that we've
Named after
covered
a
in the
beer.
past. After what?
Trappist is a beer.
Really?
Yeah.
Well,
Those
Trappist is
Trappist
are
monks.
aren't they? Who make
They were the
beer?
monks that made the beer, yeah.
Yeah. So, okay, but I.
All right, so
People just
carry it on, Bill. So anyway, we've got
Joke there,
bookmarks
but I
for
will.
you. We've got some posters. We've got some
Yes, hang on. Well,
stickers.
Special
Well, we got to
coins.
move this
Set of
along, Bill.
stickers
We're running
for-
out of time.
Yeah.
Oh, all right. Set of stickers for the entire solar system and rockets and everything.
You can also
So-
pick some pins. There's
Yeah.
all sorts of things.
Yeah,
So,
there's
you
also
know.
90th anniversary pins. We have some
So
Signs
many
of Life
goodies.
pins. We have some keychains that are there too. So
Planetary
you'll be able to
stickers.
come down and pick out any of these things if you're a winner. So if you're any of our
Beautiful
winners.
images of Saturn if
Yeah.
you want that.
All right, so Bill, we need a ball drawn.
All right, here we go.
Let's go.
All right, so spin
So excited.
the bingo balls around.
Yes, going to spin them around.
Is this the
Oh, one
first
dropped
ever
already.
double AS bingo
Okay,
lottery?
is everybody ready?
coverage?
I think so. Yeah, what's the number? What's the ball?
It is B2.
B2?
B2.
All right, well, let's see if we can navigate to this. Oh, this is where's our real
Let's see.
mouse?
Uh-oh.
Do we have a
Anybody
real
got
mouse
B2?
somewhere?
Hold on. It might have, when we did the software, maybe it...
Chaos.
There we go.
Okay.
We're getting there. Hang on.
Works. B2.
What are we on? Okay,
Oh,
wait, back
snap.
it up.
We knew
I
that a
skipped
bingo
it.
game
There
would
we
be
go.
so
One more.
complicated.
Back one more. There we
There
go.
we
B2.
B2.
All right.
B2.
So
Yeah.
B2, Sarah, this is one of your stories.
I actually got picked first.
You got
Wow,
picked
okay.
first. All right. So what are we talking about
Let's
here?
start out with
You want a
something
clicker?
planetary.
Yeah.
Okay, so this is the YSES-1 system that it was discovered by the Young Suns Exoplanet Survey. This is an artist's depiction of this system. All right, so we see one star. There's a planet here with a disk around it, and another planet on the outskirts. Now let's learn a little more. If we actually look at this system, this is the first system we have found around a sun-like star with more than one planet. So this is a big moment right here, okay? We wanted to learn more about these two worlds. There's YSES 1b, a little bit closer in, and YSES 1c. So to give you an idea, okay, the star clearly is about the size of our sun. This is about, doesn't matter. It's 326 light years away in the constellation of Musca, in that direction, if you want to learn a little bit more about that one. The inner planet is rather big. It's on the lower end of being a brown dwarf. They are both giant planets. If we take a look at this spectra right here, what we found is that the inner planet has a circumplanetary disk, and that in this disk we have actually found silicates like olivine. This is the first time we've found this kind of thing in a disk, which is really cool. But we've also found that because of the age of this system, we would expect these silicates to have clumped up and not still been there within about like 2 to 5 million years. So this tells us that in all likelihood there's some kind of collisions going on in this system that are still populating this thing. And
or maybe a moon forming.
Yeah, maybe a moon forming, right?
Oh, exomoon.
And then this outer planet has these silicate clouds. What's interesting about this is that at the temperature range that this thing is at, we would have expected these clouds to dissipate or maybe sink down into this planet, but instead we're still seeing them in the spectra from the James Webb Space Telescope as we followed up on this. Yeah. So a really weird system that's defied all of our expectations.
All right, so by the way, all these stories are the press releases, the findings of this astronomy meeting that was just held in June. So we're reporting on it now. In Anchorage, Alaska, believe it or not. So we're going to reveal the Loteria cards now, and Bill's already posted them up here for the folks in the audience. Here you go. If you have the cosmochemistry, the brown dwarf, or the exoplanets, you can check those off. So those are the first 3 draws. All right, Bill, we need another bingo ball drawn.
Here we go. All right.
I like Bill as our game master.
Yeah,
I think we should do this every time.
We have G46.
G46. Gee, that's going to be interesting. Let's get all the way down there.
Oh, gosh.
All right, so where are we here? There's I. Okay, we're getting there. We're getting there. And G46, there it was. This is so smooth, everybody. We practiced this, as you can tell. All right, G46. All right, which story is this? Let's take a look here. This looks like a study to get better distances to the gas clouds in the Milky Way galaxy. So we're making a more accurate map of our very own galaxy, the Milky Way. The way this is done is they use the Gaia positions, which is a satellite that was in orbit, taking what still's there, taking images of the whole sky, and it mapped out very, very accurate positions of stars. And as Earth orbits the sun, Gaia was getting different angles of each of these stars, and they were able to get what's called parallax distances to many, many, many of the stars. So that was the nearby distances it got. Then we started to notice, gee, we could have these stars called Cepheids. They pulsate. I can show you here. Oh, we made this animation.
Oh, I love this animation.
If I back it up a little bit, go forward. Here we go. So here's a pulsing star, a Cepheid. Now the rate at which it pulses here tells you how bright it actually is. And if you know how bright it actually is, you measure how bright it looks in the sky, you compare the two, and that tells you how far away it is. It's a little bit like you can tell how far away a car is by how bright the headlights look. And as it gets closer and closer to you, the headlights will get brighter and brighter. Well, we did this with these Cepheid stars, and we discovered they were embedded in gas clouds. So the gas clouds sort of reflected that Cepheid light, and we were able to say this cloud is at the same distance as the Cepheid star. Now, this is a fairly accurate way to get these distances, and they compared it to the distances that were measured out using more traditional methods, using hydrogen gas and things, and it matched fairly well. So it turns out this is an additional way to map out the gas clouds in our galaxy. So this one, again, our 90th Loteria cards here. Here we go. The stars, because this was using Cepheid stars, the Milky Way, and the cool GIF, which, so yeah, the cool GIF there. All right, that was the little flashing Cepheid star. So if you have those, fill them in, folks, and we'll go from there. All right, so Bill, what's our next bingo?
I'll let you know in 1 second here.
Is anybody confused by this mixing bingo?
All right.
No, it's all right. Okay, hang with us.
We have O62.
O62, that's going to be this direction. Here we go. O61. All right, here we go.
Oh, we're skipping through the sun.
I know. Oh, so, well, wait, maybe it's
Hey,
O62.
the sun!
It's another one on the sun. Laura May, this is yours.
So, fantastic story about the sun. What is not fantastic about the sun? So this is these were discoveries made by CODEX. So CODEX is a solar coronagraph. It's actually installed on the International Space Station. Let me show it to you. We have a little, so this is the instrument right here. And I believe we have, I think this is
It's a video.
Yeah, it's a video. So you can actually see that instrument right there on the top moving. That is the CODEX instrument. I actually didn't even realize that there was that instrument right on the ISS. So to bring you back to the data, here, let's go. So to give you a little bit of context, the sun, even though we see it as that beautiful round ball of gas and plasma, its influence extends very, very far, right? We know we receive the heat on Earth and all sorts of radiation, ultraviolet. And if you've seen a total solar eclipse, you might have noticed these beautiful kind of tentacles of light that extend out from the sun. That is what we call the solar corona, right? And it changes shape, it changes throughout the solar cycle, whether we're at solar minimum or solar maximum, and it's also linked to the solar wind that we are basked in, right? So it's very important for us to understand how this solar wind works, how the solar corona works. So this solar coronagraph that was installed on the ISS, so what it's doing, it's blocking out the light from the sun so that it can measure very more precisely that solar corona, and it can get information about the solar wind, how it forms, and so you can actually see that little gradient. What you're seeing move is differences in temperature, and so it's almost sputtering, right? So the sun, the solar corona is sputtering, so these are pretty amazing results. In the past, we have measured density. This is the first time we've actually measured speed, and we've measured temperature gradients. So temperature changes in the outer atmosphere. So thanks to, again, this NASA CODEX instrument, heliophysics, very, very important, also on the chopping block, by the way.
With this, I wonder about if we could tie some of these observations to the Parker Solar Probe the next time it makes a close pass of the sun. So having multiple ways to look at the sun is very important. It's another reason to support all these NASA missions.
Yep, so here in fact you can see again some of their images. Those are those little coronal streamers, those kind of lines that you see. Encourage you to see a total solar eclipse one day in your life so you can see the solar corona. But yeah, super cool instrument, super cool discoveries, and you know, we need more instruments looking at the sun. So.
All right, well, let's take a look at our cards.
So let's look at our cards here. Let me go forward. Sorry, it's being a little slow. It's struggling.
It's thinking about it.
It's thinking about it. Ooh,
I got it.
Mysteries.
Ready?
Yep.
And forward.
Great reveal. So the sun.
Lotería?
Oh, I
heard two.
I heard the first one somewhere over there. Who was first?
It was me, and I am wrong.
Oh, it's over here.
Is the
All right, we got our
person?
first winner up there.
Hi. Yay! You win the Vera Rubin coin.
Yeah, you can come down after
talk
the show.
to me afterwards.
Yeah.
The other one is the ISS and a cool GIF.
Cool GIF.
So.
It's been repeated, or GIF if you...
And the other winner, of course, you also are welcome to come down afterwards. Please, all winners, come come grab a gift.
All right, let's do another story or two. We got time.
A quick
All right.
question when he does that.
Yeah.
When there's
So you need
there's CMEs, the coronal mass ejection.
Yeah.
How long is that event when there's a massive one?
When there's a coronal mass ejection?
Yeah, how is that like they're over?
So it's fairly quick, but it takes a little while to reach us. And the modelization is very, very complicated. In fact, we have another story in there that deals with that, but it generally takes about 2 to 4 days to reach us. So even you can see the difference in between that time span of 2 days to 4 days, right? That makes a kind of a big difference. We don't always know if the CMEs are going to hit us or not, depending on how diffuse. Sometimes they can cannibalize each other when there's several in a row. So there's a lot of stuff that we still really don't understand about the solar corona, the solar wind, CMEs. But yeah, they're fairly rapid events, these kind of ejections, and then they travel in space at very different speeds.
Yeah.
Look up the Carrington event also.
Yeah.
Oh, yeah, you really want to
Yeah.
scare people.
I'll keep you awake.
All right, so
Scare people
let's
like
try
this.
another one. Yeah, let's
let's
do
go
another
another one.
story.
All right, one more. Here we go.
At least one more, yeah.
Please be the sun again.
Got a runaway bingo ball.
I had to fetch it. It fell all the way out. Okay, this is, I thought it was Z, but that's an N32.
N32. All right, we can get back to N32.
Pay
Oh,
close attention.
G.
And
there was.
N32.
N32. So let's take a look. What story is this? Oh, this is the Green Bank Telescope.
Yay.
So big telescope. In Wisconsin? Is that where Green Bank is?
Green Bank is in West Virginia.
West Virginia, okay.
Yeah.
This telescope actually fell down and they rebuilt it, which is kind of fun. A lot of astronomers were kind of wondering why to go to the trouble of rebuilding it. Well, it's for measurements like this. They took made an image of the Taurus molecular cloud. This is a dense star forming region, and what you're seeing here is actually some Herschel data. Herschel was a European satellite that measured in the infrared and was able to see very deep. Actually, Planck is the infrared telescope. Sorry, Herschel was using in the submillimeter, I believe, was a submillimeter telescope. It was designed to measure things like these molecular clouds. The Planck one was looking more into the infrared, and unless I have those twisted. If I do, I'm sorry. It's getting late here, everybody.
There's a lot of missions.
There's a lot of missions. Anyway, Herschel had 3 different wavelengths in the microns, so that's the infrared, sorry, and the Planck is in the submillimeter because it was looking at the cosmic microwave background radiation. Anyway, and the radio dish got those lines that you can see in there, the sort of thin lines that are going vertically. What I want you to notice is that thin star-forming region, that trail of gas, that's where the stars are forming in a chain. The magnetic field is perpendicular to it. Notice it's crossing this direction, so that's a feature of here. Now, what were they looking at here? Well, they were looking at complex molecules called PAHs, polycyclic aromatic hydrocarbons. Yes, long terms. Now, what these are is these are big carbon chain molecules, and they found the largest one ever. And what it was is they kept adding more benzene rings to the cyano group, anybody that loves their cosmochemistry. So this is the largest one found yet. These essentially start to form dust grains in interstellar space. So that cosmic dust that is out there is created by these benzene rings. And they think if they found one this huge, there might even be bigger ones that are out there. And this sort of chemistry can lead to things like amino acids and things that are important for life. So PAH is super interesting. The fact we're seeing them in star formation regions means they could be common to every star. If they're common to every star, maybe they're common to the exoplanets around them and the comets. So maybe life is common. I don't know. I'm doing some big leaps there, but why not? All right, so let's turn over these cards and see what we have. Maybe we have another winner or two. So, the gas. Lotería, another winner. Yay, we have a few. All right, so yay. I see several hands in the cosmochemistry and the radio. So raise your hands if you won. All right, we've got enough winners, I think, so this was a success. Now, are there any stories anybody's dying to present? Any more of them? No, we're good. All right, well, let's move on. Well, yeah, questions, sure.
Did you say that of all of the stars that we've discovered, that this is the first time that we've discovered it having 2 exoplanets?
It was specifically around a sun-like star.
Oh,
so
okay.
Yeah, we found many different systems that have tons and tons of stars. The TRAPPIST system is a really great example. It has bunches of planets, but finding one around a sun-like star is kind of difficult. Yeah.
Yeah, sun-like stars aren't that common. People like to talk about our sun being the most common kind of star or a common star. Actually, we're kind of rare. We're not as rare as even bigger, more massive stars, but there aren't that many. And it turns out Earth-like planets are kind of rare too. So we're very interested in studying these solar-like stars.
Yeah, and I think that one's really cool too because they got to take direct imaging of it. Yeah. You noticed in that image you could actually see the star and the 2 exoplanets. We can take images like that, but it is really difficult to do that, especially with like smaller type planets, which is why it's so difficult for us to directly image, say, like Earth-like worlds. But another of the missions, just to pitch the Planetary Society one more time, but we're also advocating for the Habitable Worlds Observatory. With upcoming mission, if we can get that done, that is going to be a mission that is dedicated straight to finding habitable worlds that might be places that life could exist in.
They could.
Smaller, more Earth-like planets.
Well, as our final story tonight, we want to honor a man who passed away. And Laura May, I think you're going to lead this story.
Yeah.
Fred Espenak.
Yeah, he was a very important person in both the world of amateur astronomers and professional astronomers. Has anyone here ever eclipse chased? Yeah, a couple of you. So as you can imagine, it's a favorite hobby for the staff of Griffith Observatory. You'll recognize some of our staff members here. So this is Ginger, myself, Ian Cravella, who designed that wonderful poster, and one of our telescope operators, Michael Noble. So I took them all on this wonderful road trip last year for that big eclipse we had in the United States. So this is us in Paris, not France, Arkansas. So this was right after the eclipse. You'll notice we scribbled some Griffith Observatory. There were drawings of eclipses a bunch of people had gone through. So if you've never eclipse chased, highly recommend it. It's an amazing, amazing thing to do. And this was more than a hobby for for Fred Espenak. He passed away, unfortunately, in June, and we wanted to commemorate his remarkable achievements. So right on this picture, he's right next to this globe that was designed by Michael Zeiler, in a picture that was taken by his wife, who also attended many of these eclipses. So this is a globe that features the path of all total eclipses this century. So you can see those yellow lines are where the eclipse is going to be total, right? You have to be in that little band in order to see what we call totality. He also designed a much smaller globe with 50 eclipses that goes until 2070, so you can actually find that online. And here are all of the eclipses that he witnessed, plotted on a map. It almost looks like that globe, right? And the little dots are where he actually saw those eclipses. You'll notice some of them are in the middle of the ocean. There are a lot of eclipse cruises. And this represents, by the way, 52 eclipses. So, not all total. Some of them are partials.
Now Fred just didn't go look at eclipses. He provided
so
tools,
I'm going to talk about it a little bit.
Yeah.
So he was better known as Mr. Eclipse, and I think you can see why. So these are his stats from the online Eclipse Chaser log. Anyone can sign up, by the way. You can sign up and put up your eclipses on here. Anyone here seen totality? Couple of you here, yeah.
Quite a few in our audience.
So if you have, you'll know it doesn't last very long, right? A couple of minutes, sometimes less than a minute. So if you have a look at his little badges, he spent 1 hour and 27 minutes of his life in totality. Wow. That's remarkable, right? Those are, again, some of those 52 eclipses contributed to that. So he spent quite a lot of his life. And he started, so his first one, I suspect he was a child, 1963. But then really caught the bug, I think, in 1970. It's nice every time we have a new series of eclipses that cross the United States, new people get the bug. So we just had the one in 2017 and then 2024, so hopefully that created a whole new generation of eclipse chasers, but he started in 1970. By the way, there's about 1,157 registered chasers on this site. And I believe he's the 5th chaser in the world by number of eclipses, and 3rd by time of totality. There's someone on there who's seen like 82 or something like that.
That's amazing.
So that person is the one who has seen the most. But he was also a scientist at NASA Goddard. He originally published papers on planetary atmospheres, but he eventually turned his sights towards eclipse predictions. So he started providing NASA's eclipse bulletin in 1978. Imagine being responsible for all that information for all these people who are eclipse chasing. That was his responsibility, and eventually he became highly specialized in all of these eclipse predictions. Now, eclipse predictions, by the way, is a very old science. Our oldest records date back to 585 BC, okay? And that is when Thales of Miletus is said to have predicted an eclipse. I did have to look up how you pronounce this in English. So this is a page from the Canon den Finsternische that shows the predicted 2nd of July 2019 eclipse in Chile, and this was published in 1887. So people really did a lot of eclipse predictions. They loved this. And many prestigious astronomers, of course, took part in this exercise of celestial mechanics. So this is a little map you're seeing created by Edmund Halley of Halley's Comet fame, and that shows the path of what was known as Halley's eclipse. So he predicted the May 3rd, 1715 eclipse that took place over London and the UK within 4 minutes of accuracy. Again, keep in mind, this is the 1700s. We don't have Fred Espenak's bulletins or any fancy calculations. So his successful prediction actually helped solidify the use of Newtonian physics in astronomy, and it contributed to what became known as the golden age of eclipse maps. So a pretty amazing map. And with all due respect to Edmund Halley, his initial prediction did have a little minor error in the path of about 20 miles, which he refined after observing the actual event. And this is pretty important when you're observing. This is also done by many researchers in many different fields, by the way. People in biology, people in meteorology, lots and lots of people conduct research during eclipses. There are, of course, many astronomers who are specialized in totality. And because the center of your path isn't always accessible, you want to have really good maps. So this is a snapshot of us a couple of hours before the eclipse last year. So Ginger and I are in that little blue dot. We were trying to reach that center right in April 2024 in Arkansas. So now this path you're seeing, so in between these two lines, that's about 115 miles or 185 kilometers wide. But in 2017, that path was only about 65 miles or 100 kilometers wide, so nearly half. So again, if you're stuck in traffic, if you've got rivers, if you've got the ocean,
if you've got bad weather,
if you've got bad weather, the most important one, you really want to have good predictions, and so he was very important. So his most impactful legacy is, of course, the 5 millennia, and yes, millennia, not centuries, of solar eclipse predictions from 2000 BC to 3000 CE that are detailed here on NASA's Goddard Space Flight Center website. And all this information about eclipses, solar and lunar, of course. And so you can see some of these little books. In fact, this is Ginger. I believe this is, we had this last year during our little eclipse chase, and it is one of his books. So he really was absolutely everywhere. So you can look up yourself all of that data on the NASA Eclipse website, which he was responsible for. And 50 eclipses will give you a little bit of time to hone your photography skills. So he was also, of course, a prolific eclipse photographer. Anyone here tried to shoot an eclipse with a DSLR? It's very stressful, right? It's some of the most high-stress moments of my life, and I sort of failed last year. The one in 2017 I did great, but the one last year I handled too many cameras. So this is one of his composite images of all those little different phases, and you've got totality in the middle. Some of you,
and that's that corona you were talking about earlier, those wispy lines.
So those little wispy lines, those streamers, that is the corona from 2017 when we were closer to solar minimum, so a little less activity on the sun, and you can see kind of that corona is sort of centered towards the center, right? It's almost on a little equatorial line. So that was the 2017 eclipse that went across the United States, and he received recognition for his work. He had many publications. Of course, the Royal Photographic Society's Award for Scientific Imaging in 2018. This is an image he shot in Zambia of the 2001 eclipse. So pretty beautiful image. Again, these are different images put together. And this was the first total eclipse of the 21st century. There weren't any in 2000. I think this is the image he may want to be remembered the most by. He called it Eclipsosaurus Rex. And this was also chosen as the astronomy picture of the day in October 2017. Again, it's that US eclipse that went through the United States. And this is the T-Rex statue in front of the Tate Geological Museum at Casper College. So he shot this with an automated camera. So you're seeing totality there. And it's also kind of a cool nod to the fact that he considered a career as a vertebrate paleontologist. But he also, it's a cool fact, or it's a cool nod to the fact that about 100 million years ago, when the dinosaurs were roaming the Earth, we had more frequent total eclipses because the moon was a little bit closer to us. So I think this is also his way of, or certainly he was, I think, a big proponent of not losing your childhood wonder. But you may know him, or most people know him from famously these very awesome stamps. I bought these in 2017. So these were the total eclipse stamps. One of his images ended up on the official stamps of the US Postal Service right before the eclipse. And these were, by the way, the first heat-activated stamps that they ever issued. So this is thermochromic ink. So when you put your finger on it, it revealed, if your fingers are warm enough, it revealed the moon, right? And it revealed, and again, you can see that very intricate corona. So a really remarkable stamp that he contributed the image for, and pretty amazing that also advocacy, I'm sure, was done to have that happen, that total solar eclipse was represented. And if you go on his website, you'll find all sorts of stuff. He really was the encyclopedia of eclipse knowledge. Honestly, if you ever chased an eclipse or were in any eclipse groups, you would have seen his name mentioned. So you can find really unique little things on his website, such as this section dedicated to quotes about eclipses from historical texts. And these do get used in research, by the way, sometimes. You know, when people have tried to confirm eclipses, they've been used in, I mentioned it about a year ago in an episode of All Space. There was a confirmation of a volcanic eruption through observations, quotes on observations of the moon, and how red it was indicated that there were a lot of particles in the atmosphere from a volcanic eruption. So that stuff really stretches across many sciences. So he will be fondly remembered, Mr. Eclipse Fred Espenak. So, yep. I think we can give him a round of applause.
Yeah, if anybody's eclipse chased and you downloaded the app to know, that gives you the warnings, you know, put on your glasses, take them off. Fred, all the data came from Fred. We're redesigning some of the video waysides here in the building. We're going through and updating our exhibits little by little. We're working on the eclipse exhibit, and it'll be updated very soon. Well, we're using Fred's data, and the worry was, well, what happens if NASA shuts down their eclipse website? Because NASA, as we know, funding's being worried about. Well, we were happy to know a group of astronomers is making sure that Fred's site's going to stay active and all the data will be there. So people are worried about this because it was the best.
Yeah.
It was the best you could get. If you wanted to be at the right place at the right time, you'd go with Mr. Eclipse's data.
Yep.
So yeah, thank you for that.
Absolutely.
Yeah, question?
How far into the future did his predictions?
So I think it was 3000 BC, 3000 CE.
CE.
Yeah,
a few thousand years is all.
And it becomes harder to predict in general after a certain amount of time. But yeah, just remarkable the amount, 5,000 years of calculations.
Wow.
So that's pretty,
Well,
pretty amazing.
Well, folks in the audience, if you won our first winner up there, you can come on down and get the coin if you want the coin or the other things. Anybody else that won, come on down and get a prize. And if you just want to come down and get a NASA sticker or something, you're welcome to. We're not going to stop it. So thank you so much, everybody. Again, the programs, thank you, everybody. Programs brought to you by the Department of Recreation and Parks, City of Los Angeles, and of course, we like to thank our foundation.